Presenting Tarun R Jain.
Hey folks, am I audible till the end? No? Am I audible? Okay. So let's have a quick activity before we can proceed with the session. Can every one of you stand up just for a minute, not more than a minute? Okay. So if you have built any application using LLM or any API which is through LLM, you can sit down. To those who have built any LLM based application. Okay. How many of you have heard of agents? Can sit down. Okay. How many of you have heard of Hugging Face can sit down? Okay. How many of you have heard of Mid Journey can sit down? Okay. How many of you have heard of ChatGPT can sit down? Okay. So yeah, since most of you, as you saw, right, you know what are LLMs, but agents is a very new topic. And just to give you a kind of motivation, agent is you as a human being. AI is performing every single thing as what we do. And how is it even possible? We'll look into this in this session. So before we can proceed, I'll just give a quick intro. I guess the organizers have already given an intro. So I work as a data scientist at a startup called AI Planet. So it's a Belgium-based AI startup. And I was also part of Google Summer of Code 2024 at an organization called Red Lab. I was also part of Google Summer of Code 2023 at an organization called CMI Microscope. And yeah, I've been part of Google Developer Expert in AIML for probably 1 year now. And it all started in October 2024. And the first talk which I gave after being the GD was in Bhubaneswar. And today again I'm in Bhubaneswar after 1 year. Yeah, so that's about myself. And let's talk about today's session, right? Every one of us know what Gemini is. Is there anyone who doesn't know Gemini? Okay. So we have seen a lot of sessions which have been taken by Google. It can be Google I/O, right? They focus on one product which is Gemini 1.5 Pro. In Gemini 1.5 Pro, they said something related to context window. So what is this context window? Whenever you ask any query, right? Let's say you want to build a gaming application. Once you build a gaming application, you have the entire game. So your prompt, your response. Is my voice getting recorded or is it fine? It's fine, right? Okay. So whenever you build any application using LLMs, you give a prompt, you get the response. Combining both of them, it should be relevant to your context window. So let's say your prompt is, I want to build a game. So how many words do you have? Hardly you just have 6 words, 7 words. And once you build your gaming application, you have the entire code. The code again, it can be 2000, 3000 tokens. Now let's take the another scenario. Let's say you have your own 2 hours of podcast video. So this podcast video, it has so many words, right? So you take the entire video, you copy the entire transcript, and now what you need to do is you want to ask any question from the podcast, and then you get the response. The longer the video that you put, the more the context window you need. So this is the importance of the context window, so that whatever data you give and whatever data you get, it should be within this context window. So now that you have the clarity of why 2 million is required, let's see how you can leverage this using an agent. So again, to motivate you, how many of you have heard of Andrew Vinci? Okay, there are less numbers. How many of you have heard of Coursera? Okay, there are so many of you. So Coursera, Andrew Vinci is one of the co-founders, and DeepLearning.ai, again, is the co-founder. He made a tweet saying that AI agentic workflows will drive massive AI progress this year. This tweet came around February 2023, and ever since then, there are so many open source libraries which are in agentic domain. People are building agents, and there are so many things which have been done in this particular space once this tweet was done. And why is it very important? Let's try to understand. Okay, so before I can directly jump into agents, first let's understand how we humans perform any task, right? At the end of the day, whenever you are using large language model, it's a tool to help you based on your task. So how does we human perform any task? So let's start with a basic step. First, what you need to do is whenever you are building any application, let's take an example. You want to build a gaming application. So what will be your first goal? Right? You need to discuss with the team. You need to list down all the tasks that you are supposed to perform. So this task is nothing but a problem statement. Now that you have the problem statement, you know what task you need to perform. The next step is you need to plan. What do you need to plan? How will I approach the solution? Whether I need a backend team, whether I need a front end team, whether I need a AI engineer, how will I train the model? You need to plan accordingly based on your problem statement. Once you plan, you divide your problem statement into subpart. What is the subpart? Again, as I said, once you have a problem statement, you want to define what will be my AI model, how will I build it. If you have a backend, what backend I need to use, how will I build it, how will my API connect with the front end. All this discussion will be decomposed. So you have the task, you plan them, you decompose. Now a developer will come in. Based on whatever decomposed task is there, a developer, based on its knowledge. So knowledge in the sense, he knows how to use tools, he knows how to use framework, he knows how to write code, right? If it is a non-technical person, he knows how to sell this particular code. So once the person comes into the picture, he has its own knowledge, he has its own previous experience. So this knowledge, it's nothing but a tool. This previous experience, it's nothing but a memory. So you have both these combined things as a user, and once you have this particular user who has its own experience, he will complete the task. So again, you can't directly complete the task, right? There is always a reviewer, there is always a tester. Once you complete your task, you will give it to the tester. If there is any improvement, it will come back to the user, and then you will complete the task. So I don't have to explain this, right? Every one of us know how we humans perform any task. So we have something similar to agents. So now let's understand agentic workflow, how it is built, what are the different components. We will start with an example again to understand how it is built. At the first step, you have environment. So what is environment? Let's take you want to have an LLM who can predict what will be the weather tomorrow, and then based on that, you need to decide whether I need to take umbrella or not. Now you tell me, every one of you know what ChatGPT is, right? If you go to ChatGPT and if you ask, hey, what will be tomorrow's weather? You think an LLM will be able to answer that? Obviously, no. Now, there might be someone who will argue, hey, if I ask this question, ChatGPT will do web search and it will give me the result. So, that is the different functionality. It is doing some kind of API call, it is getting the result, and then it is giving to you. But as a whole, a large language model can't predict what is happening real time. You need to have certain API calls or function calling that needs to be done, and then you will get the context, then you respond. But for a large language model, doing the web search, getting the weather report for what is happening tomorrow, it's not possible. So let's take this example. Now we are supposed to predict what will happen tomorrow, which is the weather. Now, based on this environment, you will do certain perception. So, what this perception will be is related to weather API. You look into the weather API, you will get the data. And once you get the data, the next part is brain. Once you have the data, how will you pre-process that? What will be your decision? So this decision making comes from the brain. So now that you know you have the environment, you have the perception, you have the brain. The next thing is what tools you need to use. Now that you know you have a weather API, how will I fetch that result? You need to have certain action code, right? You will go to Google, and you will type, hey, what will be the weather tomorrow? So what is Google? Google is a tool. So there are four components here now. You have the environment, perception, brain, and tool. If you combine four of them, and then if you give it to a person, he will be able to judge whether I need to take umbrella or not. So this person who is making the judgment is the agent. In simple terms, he is nothing but a human based on all the data. So now let's understand in terms of agentic workflow. So in simple terms, agent is nothing but the combination of things that you are doing. A large language model with the tools support that can fetch data in real time. So we will start with tools. In tools, you can have different kind of tools. It can be weather API search. It can be normal Google search. It can be code. If you want to interact with your own GitHub tool, you have the GitHub tool as well. From wherever you get the data, the data source is what you call as tool. So once you have the tool, next thing is action. Obviously, you know how to get the data. You know how to fetch the context. How you want to put that into the action. This is what the action component will do. So you just have to use a tool, get the information, put that into the tool, which is your action. Now the next part, which is very important, is this planning. And my talk for today will focus on how large language model can plan itself and how you can get better results. How many of you have heard the news of O1? OpenAI released O1, right? Okay, so if you have come across O1, right? In that video, what was the video about? You give the context, that is user query. The next step, what it will do is it will think. There is a tagline, that better reasoning model. So this reasoning model, what is it about? It's planning. How can it plan? You have step-by-step solution. So if you have looked at the demo very carefully, based on the user query, first O1 model will think and it will decompose the task. This decomposition of task is what we do in planning, which we will talk in today's session. Now, planning is very important. Planning is where large language models will be used. So far, if you have looked at the workflow, for tools, do you think you need a large language model just to get the weather API? No, right? Tools, it is just to get the context. Planning is where your large language model will come in. The next part is memory. In memory, you have two things. One is you have short-term memory, one is you have long-term memory. Long-term memory in the sense, let's suppose you are building any application, you go to large language model, you ask, hey, this is my code, can you fix this error? Now, every single of us who are developers, we know whenever we get the response, that response is wrong. You need to give feedback to the large language model saying, hey, this is wrong, this is the exact code. So now what is happening? It will update that memory. So updating memory again, it's a simple database query that you can do, and you can update your memory. So if you look at this entire workflow of agentic workflow, tools and memory, it's very simple. Even a simple developer can build it. Where will a AI engineer actually come into the picture? That is where the planning comes in. Now let's talk about research. So if you look at the research, this is only for the brain part. So what is the brain part? It is nothing but the planning. And if you look at brain, there are so many things that has been done in this particular space in overall just 3 years. I'm not even talking about 10 years. This is the 3 years of research that has been done in this particular space on how you can make large language model act as a human brain that can think and that can reason itself. And not to confuse with this diagram, we will go one research at a time. Okay, so now our main focus will be how agent can have feedback mechanism, how agent can perform without feedback. We will start with agent without feedback. And the first prompt technique is chain of thought. Before I can proceed with chain of thought, I want to give two prerequisites that you need. Whenever we write prompt, right? Prompt in the sense it can be anything. I go to ChatGPT, I write, hey, I want to build a gaming application. So this, I want to write a gaming application, it is very direct prompt. So this direct prompt is what you call as zero-shot prompting, where you are not giving any context, it is only simple query. So this is zero-shot. The second prompt technique is few-shot prompting. Now you want to build a gaming application, you will give the context. Hey, I need to have menu like this, I need to have my character to be like this. Whenever you give context and then if you ask a query, this is called few-shot prompting. I'll give one more example. Whenever we build any application, right, we get an error. So when you get an error, what do you do? Can you go to GPT and say, hey, I got error in this, can you fix it? What you do? Rather you paste your error message, you paste your code, and then you ask that question. So this way what you have the error message, you have the code, which acts as the context. So whenever context with query is given, it is called as few-shot prompting. So these are two prerequisites that you need to know. One is zero-shot prompting, one is few-shot prompting. Now let's proceed with this prompting techniques. Whatever I'll speak in the planning and reasoning, it's only prompt engineering, nothing else. So even if you don't know coding, even if you are very beginner to deep learning or AI, you can understand this in a very easy way. It's just simple English. So now that you know what is zero-shot prompting, what is few-shot prompting, the next thing is chain of thoughts. So what happens in chain of thought is, given a question, you need to subdivide the question into step-by-step solution. So let's take an example. So here I have two examples. If you see on my left hand side, I have ChatGPT. On my right hand side, I have Gemini. I'm asking a simple query. I'll just read the query out. I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 to the repairman. I then went and brought 5 more apples and ate one. How many apples did I remain with? So technically what happens is whenever you ask this particular query, it should directly give you the response. So whenever you get the direct response, it doesn't even make sense, right? I'm getting the response, but I don't know how to approach the solution. So what you do, you go step by step. If you look at both ChatGPT and Gemini, the first line of their response is, let's break down the steps to find out how many apples you have. Let's break down the steps. And now if you look at Gemini, it's the same thing. Let's solve this step by step. Now if I show my previous slide again, if you look at zero shot COT, so what is zero shot? Direct query. So what was my query in the previous slide? I directly asked the question. I didn't give any context, right? So what is that? It's the zero shot. So what happens in zero shot COT is you will add a particular statement that says, let's think step by step. Whenever a large language model it is set to do step by step approach, this is where you call it as to be chain of thoughts. So let's look at this example again. If you look at the example, it is telling to think step by step. So this is what you call a chain of thoughts, which is widely used in most of the agentic workflow. And if you have seen the demo of OpenAI O1, even it is doing the same thing. It will think and it will divide into small steps and then it will give you the response. So this is what you mean by chain of thought. Even if you look at feedbacks, right? If you go to Twitter, if you go to Reddit, most of them are telling that GPT-4 place chain of thought equals to OpenAI O1. They are not trained a new model. They have just used the same old model, which is GPT-4.0, and they have just added chain of thought prompt technique. And there is also one more graph if you see in O1. The training part of the O1 model is very less. Rather, the inference part is more. So, what is inference? Whenever you directly use any model, right, that is called as inference. Whenever you build everything from scratch, that is called training. Whereas the training time of O1 is very less compared to GPT-4. This is where this kind of prompt technique is very important if you want to make an LLM to reason or plan. So here, as of now, it's only agent without feedback. So whenever you get the response, right, you are not looping back to the agent. It is just asking query, giving you the response, end of the conversation, no feedback. So now let's go with one of the most advanced methods. Now that you know chain of thought is very good. It is able to think step-by-step solution. Now let's look into a very perspective way that whenever you have step-by-step solution, do you think that is the final step? Right? Whenever I ask a query, you are getting the step-by-step solution. Each step has more steps. It's not that that is the final solution. Each step will again have multiple nodes. I can create multiple step-by-step solution from a single statement as well. This is where tree of thoughts will come in. So if you look at the diagram, based on my input, I'm getting the step-by-step solution. So this is the part of chain of thought. You have the input, which is my query. I'm getting step-by-step solution, which is chain of thought. Now each step again has multiple steps. This is where tree of thought comes into the picture, where you're using trees and graphs to prepare some strategy. Now, why is this even important? Chain of thought, again, it's very easy to understand. We want to plan, we want to reason. But what is the benefit of tree of thought? If you are a marketing, if you want to get into marketing or if you want to do certain strategies, this is where tree of thoughts will come in. The major goal of tree of thought is to make the strategies or priority to be better. So how does it even happen? Let's look at this prompt. So the prompt is let's develop a marketing strategy to increase brand awareness of our new product. So if you go step by step solution, you have all the strategies that you can take. Whereas whenever it comes to strategy, each step has multiple steps that you need to encounter. This is where tree of thought performs much better when it comes to strategy based prompt technique or strategy based planning of a large language model. So far, I'll just revise. We did zero shot prompting, we did few shot prompting, we did chain of thought, and now tree of thoughts. Tree of thoughts only focus is to make strategies. And if you look at the tables right above, I've just mentioned agent without feedback. So far, we are only speaking agent without feedback. Now we will look into agent with feedback. How can you give the feedback back to the agent or large language model? This is where we have React. By React, I don't mean whatever you do for web development, right? You use some React framework to build UI or backend. Here, React it is different. So React again is a prompt technique which is used in agent. It consists of three steps. The first step is thought. So based on the user query, first it will think what it needs to do. Second, it is action. So what is this action? Now let's say I want to know what happened between India versus Sri Lanka in 2024 Sri Lanka tour. I want to have the details of who was the man of the match. So if I ask this question directly to ChatGPT, it won't be able to answer. Why? Because this happened in 2024. Whereas ChatGPT knowledge, it is just till October 2023. So whenever you want to get the real-time information with agentic workflow, you go with React prompting. So in React, first you give the query, it will think what it needs to search. So you have to do Google search, right? For Google search, you need certain keywords. This keywords is given inside thought, and next step is you do the action. What is the action? It is nothing but the search. So just observe this part. So you will search this particular query in Google and you use an action, which is the search action. If you are using GitHub, it will be GitHub search. It can be any tool that you want to do. And the next thing is observation. In observation, you have the response. Now what will happen is, from the observation, you are taking the keyword, you are giving it to the next thought. So this thought, action, observation will repeat multiple times until observation is satisfied with the response. If it is not satisfied with the response, you have certain maximum iteration, it will stop. So this is where agentic workflow just grew in a massive speed, and this was released in 2022. And the tweet that Andrew Benji made was in 2023. And this is the reason why, after the React prompt technique came in, many people got into agentic workflow. And the workflow is very simple. I'll show you a real-time example. So this is how you write the prompt. So the prompt is very simple. You just have to tell you run in a loop of thought, action, pause, observation. I told you only three things. I told thought, action, and observation. But what is this pause? So whenever you are building anything, right, whether it is agentic workflow or normal LLM based application, you need the human feedback. If LLM is generating any nonsense, you can't give any feedback, right? You just have to tell, hey, whatever observation you have, this is wrong. Can you think it again? So this loop, thought, action, observation is running multiple times. If observation itself is wrong, you can't give it to the next thought, right? This is where you need to take a pause. So now what will happen is you do the thought, you do the action. Once the observation takes place, you need to have certain pause to give the feedback to the LLM. Hey, this is wrong. This is wrong. Can you think again? And if I continue at the end of the loop, you output an answer. Answer is nothing but your observation. Use thought to describe your thoughts about the question you have been asked. So now what will happen based on the question that you have asked, it will break down into keywords. This keyword will be given to the action to think. And now you have the action to run the actions available to you. There are multiple actions that you can have. You can have weather API, you can have Google search, whatever you need to give, you can give that as a prompt. Inside your available actions are tools str. So this is where you need to provide all the tools list. And then you can run this particular code. Now what will happen is once you give the query, this particular prompt will run for multiple times and it will give you the solution. This way you have agent which feedback which can mimic very close to the humans. And let's talk about the use cases. What are the multiple use cases one are building in the enterprises? One of the major use case which we have built at AI Planet is code product documentation. So we have open source code, we have open AGI, we have beyond LLM. So whenever we have large code base, we also have to update the documentation accordingly. So what we have done is we have built an agent. Whenever we do any PR, this agent will understand the code base, which is the action. So now what is action? Whenever there is a code change, we have a function that will trigger the particular API of GitHub and it will tell what was changed. Based on that, LLM will plan and it will write the documentation. So what is React prompting doing now? It will look into the GitHub action and based on what prompt I give, it will give me the product documentation. So this is one of the use cases. The second part is assignment evaluator. And again, we usually keep hiring folks and we don't have our bandwidth to review all the assignment. So what we have done is we have built our own agent again. What this agent will do is we have a proper template. We have criteria for the particular candidate. Once we get the assignment, so now what is the action? The action is a PDF. So we will read the particular PDF and we will analyze what data you have. Based on this data, we use an agent to evaluate whether it is a fit candidate or not. So this again is one of the use cases that we have built. And the last thing is curriculum content preparation. This is very straightforward. Even a normal LLM can do it. But since we have our own curriculum page, we have a courses page. Since we want it to be similar to what we already have, this is where curriculum content preparation is one of the use cases. You can have anything. There are so many use cases that you can build. You can have itinerary planner, which can be built using agents as well. Now that we have looked into so many things, right? We looked into action, we looked into tools, memory, planning. In planning, we have seen multiple research, chain of thoughts, tree of thoughts, React. How can you actually build it? So we have a library called OpenAI, which we have built it, which is completely open source, and we can do multi-agentic workflow. So I'll give you one intuition of what multi-agentic workflow looks like. Let's go back to the example I said earlier. You want to build a gaming company, you want to build a gaming application. Then you want to plan it. After planning, you have decomposition of the task. When you decompose the task, you need a backend developer, you need a front-end developer, you need an AI engineer. So these three people, all three are expertise in their own domain. So now what happens in multi-agent architecture is you have one agent who is a backend developer, you have one agent who is a front-end developer, you have one agent who is a AI engineer. That particular agent will do the entire thing that you want that to perform. And once you get the response from the first agent, it will delegate it to the next agent. Same way it will delegate to the next agent. This way you have multi-agent architecture which is running LLM calls for multiple times. And how to build it? We have OpenAI library. And I'll just talk about each components that we have. The first component is planner. So what planner will do is based on the user query, it will decompose the task. And in this step, we are using chain of thought so that it can think and it will decompose tasks into step-by-step solution. And once you have planner, you have action. Again, action it is straightforward. It's just an API call that you need to do. If it is you want to fetch the data, if you want to load the data, you use a loader. If you want to do any kind of weather API search, you use a web browser. And if you want to use commit history, you have GitHub tool. And now you have memory. Memory is one of the major components that we have in OpenAI. What memory will do is, whenever you have the response, there might be chances that this particular response it is right or wrong. So this feedback will be taken. Based on the feedback, you have a DB which is already stored. Next time, whenever you ask the same query, it will look into the previous DB and then it will generate the response. So why is this very important? I told the same example, right? Whenever you are using any large language model, you are asking for the code. It will give you the wrong response. There are high chances you will ask the same prompt again. Next time, whenever it generates the response, you should not give wrong result. Rather, it should look into the long-term memory, fetch the results from there. This is the very important feature that we have built in OpenAI in terms of memory. And then you have admin. So what admin is? It's nothing but an agent. So what agent will do is it will combine your tool, it will combine your planning, then it will combine your action tool. So it will combine all these things and it will give it to the admin and it will perform the particular task. This particular diagram is same what you saw earlier. So you had memory, tool, action, planning, right? If you combine all four things, you have an agent. Agent, it is defined as admin in OpenAI library. Now talking about workers. Workers, it's nothing but you are dividing a single task into multiple teams. So this particular team is what you call as workers, and you're assigning this particular workers inside admin itself. So the only criteria of workers is to give the flexibility to large language model to be expert in that particular field. If you want large language model to be expert in front-end development, you can write prompt in such a way that. So let's give an example, right? Whenever you are writing prompt engineering, the first step of code should be you are an expert in XXX. So it's like if you want your large language model to be expert in backend, you'll tell you are an expert backend engineer. If you want your large language model to be expert in competitive programming, you'll say you are expert in competitive programmer. So this is where you define the role, the then you have the instruction. So this role and instruction is where workers comes in. And I'll show you the code as well. Let's jump into the code. Alright. So this is the only lines of code you need to build your own agent. And how many lines is this? Probably just 15 or 20 lines of code. And the first thing is you start with the import statements. The first thing is you need to plan. And in order to plan, you have task planner. Then you have action. So what is action? You need to have certain tool to get the information. And in order to get the information, we are using DuckDuckGo search. And then you have admin. Admin will combine your memory, tool, and planning part. And then you have Gemini model. Gemini is where we are using the LLM part that can plan, that can generate the response. So there are two things that you need to focus here. I spoke about chain of thoughts, right? And I also spoke about React prompting. Where are these used in this particular library? Task Planner has chain of thoughts programming or chain of thoughts prompting, and workers as React prompting. Why workers as React prompting? Because workers is what needs to perform the task execution. So whenever you need to execute the task, you need to have feedback. That's why React prompting is required. In task planning, you don't need any feedback. So that's where you can have some kind of human intervention. With planning, you need step by step. That's where we have chain of thought. So now let's start with the first line of code. That means you need to set up the API keys. And in order to set up Gemini, you need to have API key. You need to use the model. Here we are using Gemini 1.5 Flash, which has 1.5 million context window. And then you have temperature value. So temperature value is to provide randomness and creativity. If it is close to 0, that means you don't need any randomness or you don't need any creativity. If it is close to 1, you need creativity in the response. And once you define your large language model, the next thing is you need to plan your task. So now you have the query. Based on the query, for solution, this is where task planner comes in. In task planner, we have human intervention. So what human intervene will do is, based on the query, if large language model it doesn't know how to clarify the task, it will ask user to answer the question so that it can clarify. This way you are asking for the feedback. And then you have worker. As I told you, worker, you need to define the role, you need to define the instruction, which it is expert in. So if you look at these two parameters, I have a worker. That worker task is to act as a cricket analyst, and based on my user query, it should gather the information. Since it is gathering the information, I told you for workers, we are using React prompting. For React, you have thought, you have action. For action, you need to have certain tool, right? That tool is DuckDuckGo search. You need to define that. And you can have multiple tools. Since it is a list, you can add whatever tools you need. And then you have admin. So what admin will do is, it will combine all of them. It will combine your tool, it will combine your search, it will combine your planner, and based on that, it will assign the workers. First, it will plan, it will go step by step, and once you have the plan designed, then it will assign the workers who will get the information by React prompting. And once this is done, you just have to run your query. And very simple, how many runs did Rohit Sharma score in the third ODI match against Sri Lanka during Sri Lanka Tour 2024? So based on this real-time data, I'm getting the information using DuckDuckGo search. So this is how you can build your own agent. There are multiple libraries that can do it. We have OpenAGI, there is True AI, there is LangChain, there is Llama Index, there is Super AGI. There are so many libraries which are open source. And if you want to get this information, you can directly search awesome agents and you will find few GitHub repositories which have this particular files. Alright, so this is the GitHub repository of OpenAGI. There are tons of examples. If you want to build Agentic Workflow and if you want to use it in any hackathons, you can check those examples. We also have few cookbooks which you can refer to build your own agent. So this particular URL will redirect you to the GitHub repository if I'm not wrong. Okay. And we also have few playlists that I've added on Llama Index. And as I told, it function calling. So what is function calling? Based on the user query, it will do a search, fetch the result, and then it will generate the response. So this is what OpenAI is doing, which is called function calling. We have few videos on that if you are interested in building any LLM-based application or retrieval augmented generation. So whatever I've shared on this particular channel. It's mainly about retrieval augmented generation. To give you a glimpse of what retrieval augmented generation is, let's suppose you have your own gaming company or you have your own data. If you want a chat GPT to answer based on your own data, this is where RAG comes in. So what it will do is it will store your data in a vector database, then it will retrieve it. So this retrieve mechanism is nothing but a vector search. It will do the vector search, it will give it to the large language model, and then it will do few shot prompting. So what is few shot prompting? You pass the context, you ask the user query. So this context, it is coming from a vector database. And in order to build RAG, many people use open source, not open source, OpenAI, which is a closed source LLM. And whatever you see here, it is completely open source LLM. Yeah, this is it from the top. If you want to get access of the slides, this is the link. And the link is bit.ly, triple IT, TFUG, BHU. Okay, I'll again repeat, triple IT, hyphen TFUG, BHU. So you can get access of the slides and